In part 2, we are going to talk about circular motion in a plane. So let us take a uniform circular motion. So a uniform circular motion is a movement of an object in a circular path with a constant speed. Velocity is tangential and having the same magnitude but changing directions. Acceleration thus has to be perpendicular to the tangential velocity and of constant magnitude, always directed towards the center. Therefore, such an acceleration is known as centripetal acceleration. Centripetal implies center seeking, hence directed towards the center. Thus, for a circular motion, tangential velocity and centripetal force of constant magnitude is required. Centripetal acceleration and therefore centripetal force. So we have a circular motion here. Let us find the period, the radius vector and the angular speed. If you look into the diagram, r vector is the distance from O to P and theta is equal to omega into t. Omega is the angular velocity. Theta is the angular displacement. T is the time. So we are going to have the velocity vector v. We can write the magnitude as speed. So for the speed, it is the circumference is the distance and in time period capital T. So the distance is 2 pi r and the time is capital T. So velocity is nothing but displacement upon time or distance upon time for magnitude. So it is 2 pi r upon capital T. And hence we have the time period capital T is equal to 2 pi r upon v. We also know that the angular velocity, which is the magnitude, that is angular speed, omega is equal to 2 pi by t. Why? Because 2 pi is the angle which is subtended at the center. So the angular displacement is 2 pi in the time period capital T. Again, angular speed is angular distance upon time. So the angular distance is 2 pi upon the time period is capital T for 2 pi. So omega is 2 pi upon t. So we have angular speed omega is equal to, we multiply and divide by r. So we get 2 pi r upon tr. But we know that 2 pi upon 2 pi r upon t is nothing but v from the very first equation. So we get a relation between omega and v as omega is equal to v upon r. So that's the relation between the angular speed and the linear speed, which is tangential. Now let us find the expression for the centripetal acceleration. We take the diagram again. We know that the position vector of r is rx I cap plus ry j cap. If you resolve r into two components, rx and ry, we can also write rx as r cos theta and ry as r sin theta. So r vector can be written as r cos theta I cap plus r sin theta j cap, where I cap and j cap are the unit vectors along the x and the y axis respectively. We also know the rate of change of angular displacement is nothing but the angular velocity omega. So we can write theta as equal to omega into t. So we can find r vector as r cos omega t I cap plus r sin omega t j cap, because theta is omega t we have substituted. Now we know velocity is the rate of change of displacement. So the r vector is the displacement. So instead of r vector, we write r cos omega t and r sin omega t. So we take the derivative. So it becomes r d by dt of cos omega t I cap plus r d by dt of sin omega t j cap. Derivative of cos omega t is sin omega t, and the derivative of sin omega t is cos omega t, and multiplied by omega of cos. So ultimately when we take the derivative, it comes out to be v vector is equal to minus r omega sin omega t I cap plus r omega cos omega t j cap. We take out r omega common and we get v vector is equal to r omega into minus sin omega t I cap plus cos omega t j cap. Now we take that equation again and we find out the acceleration by taking the rate of change of velocity now. Because rate of change of velocity is acceleration, that is minus d by dt of r omega sin omega t I cap plus d by dt of r omega cos omega t j cap. So when you take the derivative again, you get a vector is d by dt of v cap, v vector is equal to minus r omega square cos omega t I cap minus r omega square sin omega t j cap. Taking out common, minus omega squares into r cos omega t I cap plus r sin omega t j cap. But we know r vector is r cos omega t I cap plus r sin omega t j cap. So substituting that, you get a vector is minus omega square r vector. So centripetal acceleration a vector is equal to minus omega square r vector. We can also write this equation centripetal acceleration a vector is equal to minus omega square r vector in terms of the linear velocity, because we know omega is v by r. So substituting the value, you get a vector is equal to minus v square upon r vector square into r vector. So what we have, a vector is minus v square upon r vector. So a vector is equal to minus omega vector v vector. Thus, we can write the magnitude of the centripetal force F is equal to mass into acceleration, which is equal to m omega square r, which is equal to mv square r, that is m omega v. Now, let us take the conical pendulum. Now, if you throw a stone, it is a projectile. If you tie the stone to a string and rotate it, it gives you a circular motion. But the same stone, if you hang it and then revolve it or rotate it, you get a conical pendulum like this. So, we can find the length L as the length of the conical pendulum, m as the mass. So if you take them, this is a circular motion round it, and that angle is theta, then m into g is the acceleration due to acceleration due to gravity is a force which is directed downwards. So we have a force which is directed upwards. But we know the tension in the string is capital T when it is at an angle theta. So we can resolve this t into components as t cos theta and t sin theta. Similarly, we can write the radius vector of the circular motion below. R is equal to L sin theta because L is the length of the pendulum. Now H is also equal to L cos theta, the height of the pendulum. That's why as resolving L vector along the x and the y axis. So we can take the diagram again. And what do you find? T sine theta is nothing but the centripetal force, which is mv square r, or that is equal to mr omega. Mv square r is the centripetal force. We can write tan theta as T sine theta upon T cos theta. But T sine theta is mv square upon r and T cos theta is mg. So you just substitute the values and you cancel out and you get v square upon rg. Substituting, speed is equal to v is equal to 2 pi r upon t. From the earlier equation, tan theta is equal to 4 pi square r square upon t square rg. So t is equal to 2 pi root of r upon root of g tan theta. So t is equal to 2 pi root of L sine theta upon root of g sine theta upon cos theta. So we get t is equal to 2 pi root of L cos theta upon root g. T is equal to 2 pi, but L cos theta is h. So that is root of h upon root of g. That's all.